Hello everyone, my name is Jinda from the University of Illinois at Urbana-Champaign. Today I'm going to talk about the FITNet paper, Identifying Fashion Influencers on Twitter. The rise of social media has affected the creation and diffusion of fashion influence, which is mainly created by fashion influencers. They distributed the influence across a broader set of tastemakers. Fashion influencers become the target audience by fashion brand companies, media companies, researchers, and so on. With abundant followers, they can influence the buying decisions of their audience through the rapidly changing trends. We aim to discover an effective way to demonstrate the fashion trends based on the publicly available resources within social media. Out of many different social media platforms, Twitter provided an efficient API that could enable large-scale crawling and research study with rich datasets. Also, Twitter contains a decent size of fashion users. However, first, we must figure out who are the fashion influencers and how do we discover these influencers to gain useful influence information. To study these problems, we separated the work into 5 parts. First, we collected fashion seeds and trained the fashion classifier. Then we estimated the size of fashion subgraph with reweighted random walk estimation. We snowball sampled to crawl over 300k machine-labeled fashion accounts and ran the page rank on the following graph. Next, we asked 55 fashion major undergraduates to validate and label the top fashion influencers as our FITNet. Lastly, we analyzed the follow, mention, and retweet relations through the FITNet and used the visualizations to support the top influencer discovery. To mine Twitter's fashion subgraph, we first needed to train a classifier that determines if a Twitter account is fashion relevant based on the profile metadata and the contents of its recent tweets. We seeded the classifier's training dataset with 4 main types of Twitter fashion accounts: individuals, brands, retailers, and media companies. We manually mapped these entities to Twitter's accounts, and finally we got approximately 11.5k distinct English fashion accounts. There are many possible features such as user profile, description, follower, and following counts. We separated them into numerical features and text features. We pre-processed text features, tokenized the tweets, and compute TF-IDF feature vectors for each account. Then we trained multiple classifiers to predict whether a Twitter account is fashion relevant with different classification models. The results shows that logistic regression and SCVM models outperform to the other models that respect the truth positive and negative rates. We chose the logistic regression model since it's more interpretable model than SVM. The results reveal that content-based features computed over profile description and the mined tweets have the highest weight. We mined the fashion subgraph on Twitter, leveraging the trained classifier. However, it was challenging to design stopping criteria. Researchers have developed methods for estimating the properties of domain-specific subgraph via samplings. So we have employed reweighting random walk because of its convergence properties among several unbiased samplers. To perform a random walk on directed Twitter graph, we randomly picked 5 seed accounts to initiate 5 random walks. We used the TWIP API to crawl 200k nodes for each run. Finally, we used the Wanxian Hurwitz estimator to devise the walk. From the results, we found that the fashion percentage for all 5 walks stabilized after crawling 50k accounts, and 60% of accounts in the sample were active. Therefore, we estimate the number of active English fashion subgraph is roughly 263k. To construct FITNet, we employ PageRank to identify the top influential fashion-related accounts. Based on easily pair work, we hypothesized that fashion accounts on Twitter often to follow other important fashion accounts that are similar to them. Starting from the 20k fashion seeds, we snowball sampled the following graph using the fashion classifier. As we crawled more accounts and grew the fashion subgraph, we computed PageRank over the network of the following relationship. which converts around 300K accounts. Combined with the choose positive rate, we have roughly 276K fashion accounts, which is similar to our size estimation. Finally, we built interface and recruit 55 undergrads from fashion-related majors to validate and categorize the top 10K fashion accounts as the FITNet. Then we crawl their tweets and index the tweets by hashtags, mentions, and retweets to explore what FITNet accounts post about and how they interacted with each other. As a result, FITNet comprises of 4,188 influencer accounts. Among them, more than half are categorized as bloggers. We measured influence of each account in 300K fashion subgraph. We found that while the top 10K and top 100 celebrities host the most influence, bloggers ultimately hold more overall influence. This shows that bloggers gain more influence as their size grows. Through examining the geographical distribution of fashion influencers, we found that a large portion of bloggers are concentrated in the fashion hubs such as New York, London, and Paris. Interestingly, some highly ranked influencers live in states such as North Dakota, Arkansas, which traditionally not considered as fashion-centric in the US. Similarly, some other top influencers live in large cities such as Stockholm and Sydney, which are not considered fashion-centric. To understand how influencers influence each other, we measured reciprocity in the following relation network. As a result, this phenomenon could be ascribed as homophily, which is when top influencers in the community follow one another and form social clusters. For example, this figure shows that bloggers follow everyone, including brands, retailers, and media accounts. In comparison, celebrities often follow a very small number of accounts when compared to the number of followers they have. We also found that retweet behavior patterns generally mirror the mention patterns. This figure displays who interacted with influencers. For example, in the influencer categories, bloggers are most influential category. They are heavily followed, mentioned, and retweeted by other categories. In non-influencer categories, luxury fashion brands, PR marketing agencies, and beauty brands interacted with influencers the most. We designed FITNet's data representations to enable discovery. We first index tweets by hashtag and then retrieve the set of accounts within the FITNet that tweeted about a specific hashtag. Next, we demonstrate how structure of the hashtag-related interaction subgraphs reveal influencers who are influenced by specific fashion topics. Sustainability is increasingly become an important topic in the fashion industry. For example, if a fashion brand is trying to expand their product to include sustainability, they might want to find influencers on social media to promote their new product line. In our FITNet dataset, they could curate the sustainability hashtag to retrieve all the accounts that have previously used that hashtag in a tweet. This figure provides evidence of sustainability tweets, where influencers from the clusters mention each other. Therefore, we can identify that these influencers would be good candidates to promote fashion sustainability causes. In conclusion, this work is the first step towards studying the diffusion of the fashion influence on social media. In our future work, we can expand to other social media platforms and leverage FITNet to build systems that monitor fashion influencers. Since fashion influencers are the test makers of the fashion industry, such monitoring system could also enable researchers to study the evolution of fashion trends, capture them as they happen, and possibly even predict future ones.